So hello everyone, welcome to this video, and in this video I will be explaining the problem maximize the topmost element after key moves. So in my opinion this is a little bit difficult problem, not medium, because it has a lot of edge cases involved and you can do it. In fact I did submitted wrong answers many times, and when I was able to submit the correct answer my code was all messed up. It was not very clean. There were a lot of if else conditions. So basically what I was doing was I was checking what test case failed, and then I was realizing that, oh, I didn't consider this edge case. So I was just keep on adding those cases, and then eventually my answer got submitted. So I hope you have already read the problem. So in this video I will be explaining the various edge cases, and I will be solving also, and then I will be writing those edge cases in the code. So the problem is basically saying is that you have a nums array and you have certain operations and you have to perform those operations. So one of the operation is you can remove the topmost element from the pile, or you can add any removed element back into the pile. Pile is this nums. Okay, so let's get into the conditions. So the first condition is there can be various cases. Okay, so the first case is, okay, let's say if k is equal to 0, this can be a case. Let's say you have only one, you can do only remove only one time. Okay, let's say that the number of operations is greater than the size of the pile, or let's say this number of operation is less than the size of the pile. So basically these are the different edge cases that can be possible. These are the number of operations. Okay, so our cases will be based on this. Okay. So here if you don't have any move, then what will you return? So also in this problem it is given that the nums length is at least 1, so we can say that we will always get a pile. So if this is the case, then you will return just the first answer, the first topmost element of the pile. It is pretty clear. So our this edge case is sorted. Now let's code it. So I have already written the size. If n is equal to nums dot size. Now if k is equal to 0, then I will return nums 0. Pretty straightforward. Okay, now our second edge case will be, suppose k was 1. Okay, k was 1, you could make only one move. Then what would have been possible? So suppose there could have been two cases. Either the pile could have been like this, basically its size would have been more than 1, or its size could have been only 1. So in this case you have to remove any element. So you will remove the first one and then you will return this one. Always this will be the case. And if this is the case that you have only one, the size of the array is always 1, then you will have to remove it and you will have nothing to return, so you will return -1. It is given that if the pile has nothing, the pile is nothing after k moves, then return -1. Okay, so this is our second case. So let's write it. So if k is equal to 1, then return what? I will write it in ternary operation. So if n is equal to 1, basically the size of the array is 1, then question mark, I will return what? -1. And if it is not 1, then I will return the basically the first element. I mean the second, you understand what I am saying, the second element. I will return the second element. So this is our second condition. Now let's move towards our, this is also sorted. Now let's move toward this condition. So this is a interesting condition. Okay, so if k is more than n, so basically you have an array of size, let's say 200. Okay, and you can make 20,000 moves on it, 20,000 moves. So basically you can, if you find the maximum element in this array, you can just keep on removing it and adding it, keep on removing it and adding it. So this is our uh, second condition, and also there is one more sub condition inside this. The sub condition is that suppose if you have the size of the array is 1, the pile is 1, then if you have like let's say 3 moves, basically this is an odd number. Okay, so what will you do? You will first remove it, then add it, then remove it. Okay, so basically if the size is 1, then if you have got odd number of moves, then you will have to return -1, because there will be nothing left in the end. And if you have even number of moves, then you will return this element itself, because you will remove it, add it, remove it, and then again add it. Okay, so this is the sub condition here, and the other sub condition is this one, that you will simply return the max element. So let's score it. So here, if k is greater than n, so our first condition, sub condition, is that if n is equal to 1, that is you have only one element, then our answer would depend on the number of moves. So for example, k%2 is basically that you have got even number of moves. If you have got even number of moves, you will simply return the first the topmost element, and if you have got odd number of moves, you will have to return -1. So this is the condition, and if n is not equal to 1, then you will simply return the max element. So in a vector, if you want to get the max element, you will have to write max element nums dot begin comma nums dot end. So in this, what this does is it returns the max element in this nums vector. Dot begins means starting and dot end means end. So you can write 4 here, it will return between the first and the fourth element the maximum. So this is how it works. So this is our third condition. Now moving towards the fourth condition. So fourth condition is the most challenging one. Okay, so let me just, okay, it is not possible. I will choose the pen again. Okay, so the fourth condition is k is less than n. Okay, so let's make an array. It will also have some sub conditions, so let's write things in it. Okay, 2, 8, 7, 15, 4, 19, 100 and 8. Okay, so this is the if k is less than n. So what will happen is that suppose the number of moves is, let's say k is equal to wait a second. Okay, so in this example, in this case, if k is less than n, suppose if k was equal to 4, then I will see that in this range from 0 to 4, the max element is 15. But if I remove everything, I won't be able to add 15 back. Okay, if I remove 3 elements, I will be having the maximum element as 7 in my hand, and I have one move left. So either I can add back 7 or I can remove 15. So the condition here becomes is that if the kth element is 15, kth element is the max element, then the max element that you will return will not be 15, it will be something, it will be either be 7. So here in this, if this was 14, when you have the last move on 15, you will remove 15. Okay, because if you remove 15, then the topmost element will be 14, but if it was 4, the better move will be to add back 7. So around these conditions, there are some sub conditions. So I prefer that I will write the code and then I will explain it, because it will be much more better. So if k is less than n, then I will try to get some numbers. So int mx, so mx will be the max element between 0 to k. So for example, if k is 4, then the max element in 0 to 4 will be the mx. So mx will be, let's copy this thing, star mx nums dot begin. So in this case I don't need to go to the end, I will just have to write nums dot begin plus k. So this is my max element between 0 to k in the pile. Now I will write another condition. This will be second max, it will be between 0 to k minus 1. So for example, in this case, the second max is mx is 15 and second max is 7. So second max is 7. So this is my second max, and I will write another variable here. It will be int nx. Int nx will be the next element. Basically after 15, this 4, this will be the nx element. I will explain you why I am writing this. So nums k, so this is the next element, and I will write another variable int kth. Kth is equal to kth will be the kth element for fourth element, that is 15. So I have the boundary element, so kth will be nums k minus 1. So these are my 4 variables, and now my conditions will revolve around this. Okay, so the first condition here will be if nx is greater than mx, then I will return nx. What does this mean? It means that suppose in let me take the blue pen. So in 0 to 4, the max element was, let's say, 15. Okay, but after this is the nx. Okay, nx, but let's say nx was 4000. Okay, so nx is basically greater than mx. So in this case it will be favorable for me that one by one I will remove all elements. So that's why I will return nx. Okay, now my second condition will be else if kth is equal to mx. Okay, so in this condition what I will do, I will return max of second max and nx. This is because suppose in this case the mx was 15. Okay, but I can't make this my topmost element, so I will have a choice either to remove this element and go with the nx, or I should put back here the second max. So sorry, in this case the second max is 8. My bad, it was not 7. So it will the answer, what decision I take will matter on either which one is more, is the second max more or the next one is more. So for example, in this case the second max is more, so it will be better for me if I put back 8 in as the topmost element. And if suppose this 4 was 4000, then it would have been better for me if I remove 15. So this is how my second max will depend. Now the third and the last sub condition will be return max. So basically, if suppose in 15 all these conditions are bypassed, and let's say the max one was here, let's say 8,000. Okay, so if 8,000 was the max, then I will simply return 8,000. That's why. So these are the conditions. Also there will be one more condition that I missed, and it is uh, if k is equal to n. I said that this has a lot of edge cases, and it is possible that you can miss out. So if k is equal to n, so this will make a similar story like this. So for example, if the size of the is 3, okay, the size of the array is 3. Let's write 8 4 15. Okay, the size is 3 and k, you have got 3 moves. Okay, so and here you will have the max and the second max. So here the max element is 15 and the second max is 8. In this case, your answer will be always second max, because if you reach towards 15, if you keep on removing everything, you remove 2 elements. Now if you remove 15, your answer will be -1, because there will be nothing left. So in this case, since the last element is the basically the kth element is the max element, so in this case you will return second max. Okay, and suppose if the kth the max element was not the last element, suppose this was 80, then this will I will obviously return 80, because in the last move you will decide to put back 80 in the top row. So let's write this condition. So if k is equal to n, so I will write these things basically: int max and int second max. Okay, so I have written both of these. So here return mx is equal to nums k minus 1. So if the max element is the last element, then you will return the second max, and if that is not the case, then you will return max. Okay, and in the end I will just write return 0 here, just so that I return something, but everything will be handled in these 3 4 5 cases. So basically, let's compile the code. So these are some of the edge cases that I failed when I was writing the code. It is taking some time. So let me summarize basically. So the first condition is that if you have 0 moves, you will return nums 0. Okay, something happened. Okay, something is wrong. It seems I missed one edge case, -1. Okay, let me see. So this edge case I missed. Okay, so I paused the recording and looked back into the code. So the mistake was basically in this line. Basically, if n is equal to 1, then if k%2 is equal to 0, so by default this means 1, this means true. So I had to write is equal to 0 here, because like if the number of moves are even, then you will simply return the first element. So this was the reason for the error. Now let's submit it. Man, I got this wrong a lot of times, and it happens that while explaining sometimes I fumble up the coding part. So I hope you have understood the various edge cases, and if you just write them yourself and spend some time with it, you will surely understand. It is taking some time. So the first case is k is equal to 0. Second one is you have got only one move. Second one, third condition is you have more than n moves, so it got submitted. So it has two sub conditions. The third one is you have got exactly n moves. The fourth condition. The fifth condition is basically this. So from code part, not that much, but from understanding part, there are a lot of conditions. So if you have understood the problem, do like the video and subscribe the channel. So thank you and have a nice day. Bye bye.